Welcome to another video for valuation of bonds and shares. In this video, we'll look at an example of yield to call for bonds. ABC Corporation's bonds currently sell for rupees 1,275. These bonds can be called in 5 years at a call price of rupees 1,120 and pay an annual coupon of rupees 120. What is their yield to call? So let us first note down the information that has been provided to us. So the bond is currently selling for rupees 1,275. So basically the market price of the bond is 1,275. Now these bonds can be called in 5 years. So basically the time frame to call back is 5 years at a call price of rupees 1,120. So call price is 1,120 rupees and pay an annual coupon of rupees 120. So annual coupon is 120 rupees and we have to find out the yield to call. Now what is call price? So this is the price which the bond issuer will give back to the investor at the time of buying back the bond. So this is similar to the maturity value. So now let us draw the timeline. So this is the timeline that I've drawn for this bond. Now here we have not been given the maturity time frame for the bond. So we are assuming that the maturity is happening sometime after the 5th year. Now the market price of the bond is 1,275 rupees. I have put a negative sign showing that this is a outflow of cash from our pocket. And every year we are going to receive an interest of 120 rupees, which is shown as positive sign because this is a inflow into our pocket. Now, irrespective of the maturity time frame, basically the bond is going to be called back at the end of 5th year. So at this time frame. Now at the time of call back, the investor will be paid an amount of 1,120 rupees per bond. So the investor is going to get 1,120 rupees along with 120 rupees in the 5th year. So here we have to find out the yield to call, or in other words, what is the yield or rate of return on the investment till the point when the bond is called back or bought back. So till this point. Now the rate of return will be the rate at which the present value of the bond becomes equal to the present value of the cash flows, that is the interest and the call price. So let's say this is the current price of the bond represented by B0. Now we have to equate this B0 with the present value of the cash flows. So we have to find the present value of all of these interest along with the call price. So let's say this is PV1, PV2, PV3, PV4, PV5 and PV6. So here we are trying to find out the yield to call. So basically when we add up all these present values, the rate at which this total is equal to the value of the bond is the yield for this bond till the point it is being called back. So basically B0 is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5 plus PV6. Now we know that present value is equal to future value divided by 1 plus I to the power n. So in this case, till PV5, the future value is the interest, and for PV6 the future value will be the call price, and for I, so this is the rate of return, so in our case this is yield to call. So basically B0 is equal to INT divided by 1 plus yield to call to the power 1 plus INT divided by 1 plus yield to call square plus INT divided by 1 plus yield to call cube plus INT divided by 1 plus yield to call to the power 4 plus INT divided by 1 plus yield to call to the power 5 plus call price divided by 1 plus yield to call to the power 5. So now let us plug in the values. So the current price of the bond is given to us as 1275. So this is equal to 120 divided by 1 plus yield to call plus 120 divided by 1 plus yield to call square plus 120 divided by 1 plus yield to call cube plus 120 divided by 1 plus yield to call to the power 4 plus 120 divided by 1 plus yield to call to the power 5 plus call price is 1120 divided by 1 plus yield to call to the power 5. Now we can try and solve this equation by trial and error method. So we will have to enter a value for the yield to call and see if the right hand side is equal to the left hand side. If the right hand side is greater than the left hand side, then we have to reduce the value of right hand side, and so we will have to increase the value of the denominator, that is the yield to call. But in case the right hand side is lesser than the left hand side, then that means that we'll have to increase the value of the right hand side, and hence we need to decrease the value of yield to call. So let us first enter the value of yield to call as 7. So we'll equate the right hand side and then we'll compare the outcome with the left hand side. So the right hand side is 120 divided by 1 plus 0.07 plus 120 divided by 1 plus 0.07 square plus 120 divided by 1 plus 0.07 cube plus 120 divided by 1 plus 0.07 to the power 4 plus 120 divided by 1 plus 0.07 to the power 5 plus 1120 divided by 1 plus 0.07 to the power 5. So this is equal to 120 divided by 1.07 plus 120 divided by 1.07 square plus 120 divided by 1.07 cube plus 120 divided by 1.07 to the power 4 plus 120 divided by 1.07 to the power 5 plus 1120 divided by 1.07 to the power 5. So now after calculating this, the value we get for the right hand side is 1290.56. This is rupees. But the left hand side is equal to 1275 rupees. So these two are not equal, and right hand side is more than the left hand side. So we need to reduce the right hand side. Now in order to reduce the right hand side, we have to increase the denominator. So instead of 7, let's now take 8. And let's then calculate the right hand side. So we'll enter yield to call as 8. So the right hand side becomes 120 divided by 1.08 plus 120 divided by 1.08 square plus 120 divided by 1.08 plus 120 divided by 1.08 to the power 4 plus 120 divided by 1.08 to the power 5 plus 1120 divided by 1.08 to the power 5. So after calculation, this comes out to be 1241.37 rupees, whereas the left hand side is equal to 1275 rupees. So when we put the yield to call as 8%, we get lesser value than the value of the bond. And when we put 7%, we get more value for the right hand side than the value of the bond. So basically, the right hand side will be equal to the left hand side at some point between 7 and 8%. So let's try to find that. So at 7%, the value of right hand side is 1290.56, whereas at 8%, the value of right hand side is 1241.37. Now we want the value of right hand side to be 1275. So it is somewhere in between. Let's say it is here. So this value is 1275. So in order to come to 1275, basically the value 1290.56 has to reduce by 1290.56 minus 1275, which is 15.56. And the total difference between the value at 7% and at 8%, this is 1290.56 minus 1241.37. So this value is 49.19. So the gap of 1%, that is from 7% to 8%, leads to a gap of 49.19 in the value of right hand side. So now we have to find how much percent will lead to the gap of 15.56 in the value of right hand side. So 49.19 leads to a gap of 1%. So 15.56 will lead to a gap of how much? Let's say x. So let's do cross multiplication. So x into 49.19 is equal to 15.56, or x is equal to 15.56 divided by 49.19. So this comes out to be 0.316. So basically 7% has to be added to 0.316 to come to this point here. So 7 plus 0.316 becomes 7.316%. So at 7.316% value of yield to call, the right hand side will be equal to 1275, which is also the left hand side. So basically the value of yield to call is 7.316%.